In this lesson, we're going to be studying the arc length formula. For a circle of radius r, a central angle theta in radian measure, that's bold, it's underlined, it must be important, it doesn't say degree measure. So for a circle of radius r, a central angle theta that's in radian measure intercepts an arc length of s given by, here's our formula. All right, let's get a little picture of this, what's going on. Okay, here's our circle, so go ahead and draw the circle. At the center of the circle, I'm just going to go ahead and extend and draw a radius, so we'll label that R. And then I'm going to go ahead back to the center and go to the circumference again. It's not supposed to be 90. We're going to call this angle, this central angle, theta. Remember, theta has to be in radians, not degrees. It intercepts an arc length of s, so the distance from this ray to this ray along the circumference is called the intercepted arc length. That's an arc length, a piece of the circumference. Now that distance, and let me label that s because we're defining our variables. So in this formula, we have s, r, and theta. So s represents a distance, an amount, a piece of the circumference, if you will, of the circle. Theta is the angle not in degrees, but in radians of that central angle. And r is actually a distance here from the center to the circumference. So if we want to know what this distance is, all we have to do is multiply the radius times the angle measure, as long as it's in radians. If it's not in radians, if the angle's given to us in degrees, that's no problem. We'll just multiply by one of the conversions to change that degree measure to a radian. So we might have to do a little extra work, depending upon if theta is given to us in degrees. It says, note that if r is 1, so if r is 1 up here, then s equals theta. So that means the radian measure of theta is equal to the arc length. All right, we got a set of problems here that's going to involve r using this formula. So it says, find the radian measure of the central angle. I'm going to decode that. So what am I finding? I'm finding a radian measure of the central angle of a circle. So I'm finding theta given r that intercepts an arc length of s. So this is r, and this is s. So it sounds like the question is find the radian measure of a central angle. Sounds like I'm finding theta. So this formula is well and good, but I'm not solving for s because notice they give me s's distance, 10 feet. And then they're also giving me the radius, which is 22. So 10 is quite a bit smaller than 22, so my angle should be kind of small. All right, so I'm going to go ahead and put the formula right here, but what I'm going to do is I'm solving for theta. So I'm going to divide both sides of this equation by r. So then I'm going to pull that over here. What I'm trying to find is theta equals s over r. So theta equals, s is 10. You can include the feet if you want or not. And r is 22 feet. But these feet are going to cancel anyway. They'll divide out. So let me come up here. So theta is equal to 10 over 22. That's my answer. I mean, I guess we could reduce it to 5 over 11. Did it want me to change my answer to a decimal? Doesn't say. But if they did, then I would divide. I wouldn't put the fraction template there because it'll probably just return as a fraction. So if they wanted a decimal answer, I'd do 0.45, round it to 3 decimals, 5. And remember, this is radians, not degrees. All right, I don't really care where you stop, doesn't matter, but don't stop at 10 over 22, I guess. Go ahead and reduce it to 5/11ths. So that makes sense, about a half a radian. And that's because the arc length would only be, if you draw a picture of this, the arc length would only be about 10. If this is 22, then 10, well, here, let me just draw 10 would be about right here. If I kind of try to make sense of this, is if this radius length is 22 and the arc length is half of that, then I'm not going up very high. So I should be definitely less than 1 radian, and 0.45 is definitely less than 1 whole. All right, same thing with example 2, same formula and everything. So you might want to pause the video, work on that on your own, and then you come back and check your answer. You get 2 radians. So it's theta equals S over R, so 160 kilometers over 80 kilometers. I'll just not even write the kilometers down. And that is definitely going to give us 2 radians. And if we think about it, that makes sense too, because if the radius is 80, if this is 80 kilometers, then I'm going to have to do 80 to get to 160, another 80. So it makes sense that I'm about at 2 radians. All right, for this next group of problems, we're finding the length of the arc on a circle. So what that's telling us is we're finding S. They must give us radius and theta. So they do, radius and theta. And it's in radians, that's good. This is not in radians. We're going to have to multiply by pi over 180 degrees to convert that to radians. Okay, oh, what is that number? That's 9. It's a 9 there. All right, so we're finding S. So I'm going back to the formula. Okay, the formula is intact, so I'm going to actually use S equals R theta. So for this problem, I'm going to kind of do this. The radius is 9 times theta is pi over 3. I'll put 9 over 1. I can go to my calculator, but it's just as easy to divide out the 3's. So it looks like my arc length is 3 pi. But for me, I'd prefer a number for this. So let's change that to 3 decimals by multiplying 3 times pi. 9.425. And we should have a unit for this. The unit would be, well, the units of the radius is feet, so it must be this, the intercepted arc length is also feet. All right, so let's make sense of this, just a little picture. Okay, for these problems right here, just think about having an angle of pi over 3 radians. That's about right there. And if the radius is 9 feet, if this is 9 feet, that looks like 1 radian. So if I'm up here, then I would think that my answer should be about, this intercepted arc length right here that I'm trying to find should be about 9, and it is. All right, let's see if we can kind of predict what the answer is to this for the arc length. So if I measured out an angle whose degree measure was 135, I'm about right here. Now let's say the radius is 12. So I'm going to go ahead and complete this circle. So if the radius is 12, then this is 12. This is another 12. I'm thinking my answer should probably be more than 24 because it looks like I have 2 12s to get over here to this angle. All right, the radius is 12. The angle is 135 degrees. But remember, we don't want degrees, radian measure, so let's just go ahead and attach that conversion fraction onto the end. We can go all straight to the calculator. And I think I got 28.274. Now the units of the intercepted arc length will be the same as the units of the radius, so that's going to be centimeters. And it looked like with the radius of 12 that I had to double that to get over here to that angle. So I said more than 24, and that number matches up with what I predicted. All right, for this third section, we're finding the radius R of the circle. So we're finding R. They're going to give us the arc length and the angle. They're going to give us S and theta. So, yep, here's S and here's theta. All right, so I'm finding R. So S equals R theta. Let me manipulate this equation. If I'm finding R, I want to divide both sides by theta. So R equals S over theta. Okay, so for this first example, the arc length S is 3. I'm going to divide that by theta as long as it's in radians, so 4 pi over 3. Alrighty, I'm gonna come up here. Keep, change, flip, but we'll just do this all on the calculator. So we got a fraction inside of a fraction, don't we? So 3 here, down here, let's build another fraction in the denominator and put 4 pi over 3. Should change it to a decimal, 3 places. So the radius equals 0.716. The radius should have units, and the units would match the arc length, so that's meters. So both the radius and the arc length should have units on them. The angles should just be labeled rad, or just don't even have rad on there. Alrighty. We could draw a picture to confirm, but I think I've made my point on the pictures and the predictions. Okay. All right, next problem. Still finding radius, and it's s over theta, so fraction s is 8. Theta is 330 degrees, but let's go ahead and attach times pi over 180 degrees down here. Alrighty. So we're going to definitely use the calculator for this work. So 8 over, now down here, I need another fraction in the denominator. So I'd go ahead and combine and get 330 pi and then 180. Hopefully that'll do it. Yep. So 1.389. It's a radius we're finding. It should have units. It matches the units here on this intercepted arc length, so inches. So just to recap, what have we learned so far? Well, we've learned how to use the arc length formula, S equals R theta, but we've used it to find not only the arc length, but also the radius given the other two quantities. We also used it to find the theta given the other two quantities as well. Okay, now an application problem involving this formula. Fold it down a little. All right, find the distance between the cities, Dallas and Omaha, Nebraska. Well, I know Omaha is due north. Just jump on 35 and you just start heading north, and eventually you're going to bump into Omaha. So find the distance between the cities. Okay. So because we're using S equals R theta, I'm trying to think about, okay, which one of these quantities am I finding? Well, I'm not finding the angle, I don't think. I mean, it's asked me to find the distance, so I'm thinking I'm going to find the arc length. Okay, not the radius. Let's read on. Find the distance between the cities. Assume that the Earth is a sphere, okay, a circle, whatever, two-dimensional, of radius 4,000 miles. Got it. So R equals 4,000 miles. The picture is becoming more clear about what I have and what I'm finding. So they gave me the radius, and then it says, and the cities are on the same longitude. One city is, oh, I do know that, due north of the other. So the Earth is a sphere, so we're actually on, kind of an arc, so to speak. So here's our latitudes right here. So notice that they've given me the degree measures of the latitude of both Dallas and Omaha. Well, they're giving me the degrees. So I am actually finding the distance between our cities along the circumference of Earth's surface. So I am finding S. I just first had to figure out which arrangement of this formula I'm going to be using. So the distance is actually going to be the arc length. So I got it. So S equals, R is 4,000. All right, now the angle would be the angle between these two cities. So I'm going to have to subtract these degree measures and then multiply by pi over 180 degrees, because remember, theta has to be in radians and these are in degrees. Okay, So how do I set this up? Let's see, Omaha has a larger degree than Dallas. So I'll put Omaha first to get a positive measure. So let's record our work and then let the calculator help us. Oh, look, we get to revisit the degree, minute, second keystrokes. All right, so all of this is our theta, but it's in degrees. So remember, we don't want degrees, we want radians. So I have to tack on the pi over 180 degrees. So this is r theta, this is r, this is theta, but this is in degrees, so that's why it requires that extra multiplication, that extra factor. All right, let's see if our answer makes sense when we get it. I know Kansas City is probably about 500 miles from here, maybe 450. And Omaha's north of that, so I'm thinking it's 550, 600. That's gonna be my guess, just because I've traveled that way. All right, all calculator work. Remember, the little quotation marks is green and then the plus key. All right, let me just check it all. Looks good. Multiplied, subtracted, got to put that in parentheses. Okay, all looks good to me. I'm just going to hit enter. Oh, yeah, I thought it was about 550, 600 miles, and that's about right. So 591 point, we'll round to 3 places, 298. And the units are miles. So this was a cool little problem because we got to use our new arc length formula, S equals R theta, but we also got to revisit the degree, minute, second keystrokes on our calculator. All right.